The Russian Air Force is collapsing. Not retreating. Not rearming. Collapsing. 3 years into the war, Russia, once expected to dominate the skies, is running out of jets, pilots, and options. What was supposed to be an overwhelming advantage has turned into a slow-motion disaster. Catastrophic losses. Engine failures. Aircraft pulled from museums and scrapyards. And now, U.S. intelligence says Russia's airpower may never fully recover. This isn't just about jets being shot down. It's about an entire system breaking under the weight of war, corruption, and decades of bad doctrine. So what happened? How did Russia lose its edge in the skies? And what does that mean for the future of modern warfare? Let's break it down. This problem for Russia didn't really start in 2022, as a more dedicated analysis shows symptoms of this far before the conflict between the two countries started. But let's start by examining the most visible and discernible symptom of Russia's air power crisis: direct combat losses.
According to the meticulous documentation by the open-source intelligence site Oryx, Russia has lost at least 141 fixed-wing military aircraft that have been visually confirmed as destroyed, damaged, or captured. This includes frontline fighters like the Su-35S, bombers like the Su-34, and various other tactical aircraft such as transports and radar or airborne early warning and control craft. This represents around 10% of Russia's total fleet size before the war started. The 10% figure here is important, as a double-digit loss rate of an entire system such as the Air Force would start eating away at Russia's ability to conduct airstrikes and exert localized air superiority over its own skies. Due to Russia having a significantly larger land area than Ukraine, its aircraft need to cover much larger distances to patrol the skies or respond to long-range strikes deeper into Russia's territory. Given that Ukraine has steadily increased its capacity to launch drones deeper into Russia and with greater precision, managing to take out 10% of Russia's air force would further degrade the latter's ability to mount a layered anti-air defense system. But the visually confirmed losses represent only part of the story. Ukrainian military sources claim to have downed over 340 Russian planes and as many helicopters by early 2024, only 2 years into the war. These figures could have been inflated for propaganda, morale, and geopolitical purposes, as they are pretty much impossible to verify, given that Russia will practically never admit to the true extent of its losses in Ukraine. At best, we might get the precise scale of the casualty and loss rates years after the conflict is over and the documentation is revealed. But given that Oryx only counts verified damaged and downed aircraft, chances are many more planes were damaged, but without explicit imagery to corroborate that fact. As such, it's likely that the true number of aircraft Russia has lost lies somewhere in between these two figures, pointing at above a 10% loss rate. What makes these losses particularly devastating isn't just their quantity but their quality. Russia has lost a solid percentage of its most advanced aircraft. These are planes that require years of manufacturing and highly trained pilots who need thousands of flight hours to reach combat proficiency. The Su-34 fullback strike fighter provides a telling example. This advanced aircraft, which entered service in 2014, was supposed to be Russia's premier precision strike platform, with an approximate unit cost of $36 million and a production rate of only about 6 aircraft per year. Russia has lost at least 37 confirmed Su-34s, equivalent to roughly 3 years' worth of production. If Russia can consistently churn out as many of these aircraft as it can lose, then there's no real problem here. But the truth is much more complicated. For one, the visible losses of aircraft shot down over Ukraine represent only the tip of an iceberg. Behind the scenes, Russia's remaining aircraft fleet is deteriorating at an alarming rate due to what military analysts call imputed losses. These are the cumulative effects of overuse, inadequate maintenance, and parts shortages. According to a RAND Corporation analysis from late 2023, Russian combat aircraft were flying 3 to 4 times their intended annual flight hours. Throughout the war, these come from the fact that Russia has been using them to deploy glide bombs, which we'll cover a bit later, and from the fact that Russian airstrips are located further away from the front line than Ukraine's. The increased usage of the aircraft directly goes against the traditional doctrine of aerial warfare, that being modern fighter jets designed for specific operational tempos, i.e. flight hours per year, with maintenance schedules built around expected
Usage pattern.
When these limits are exceeded, aircraft are more likely to experience catastrophic failures on several systems, which makes them an outright liability in the grander scale of the conflict. This overuse is compounded by Russia's increasingly desperate tactics. To avoid Ukrainian air defenses, Russian pilots fly at extremely low altitudes, putting tremendous stress on airframes and engines. These high-stress flight profiles accelerate wear on critical components, particularly engines, which are already Russia's most significant maintenance bottleneck. The Su-35S, Russia's most advanced operational fighter, utilizes Saturn L-41F-1S engines that require maintenance after approximately 1,000 flight hours under normal conditions. The total lifespan of the engines used by the Su-35, a relatively modern fighter, ranges from 4,000 to 6,000 depending on the exact model of the engine used. However, 1,000 hours is the generally accepted rate at which the engine needs to be rechecked completely, which can ground the airplane for weeks at a time. However, those operating conditions posit a near-perfect flight environment and operations, far from what is happening in Ukraine. Instead, Russian aircraft need to either surface skim to avoid long-range radar, repeatedly used their afterburners to achieve high speeds to evade Ukrainian countermeasures or maneuver around the Ukrainian airspace entirely when deploying medium-range weapons. Flying close to the ground generates more heat and allows the craft to intake more debris, which has been shown to have a noticeable reduction in lifespan. For example, F-16s flying in Syria had their lifespan reduced by 20% by taking on sand during takeoff procedures in the desert. Something similar is likely happening to Russian aircraft, even if it's on a smaller scale. And even if an aircraft takes damage and manages to return, its radar cross-section can be suddenly modified due to the broken stealth coating or deflecting pattern. This makes an aircraft more likely to be picked up by radar, which severely increases the risk of engagement. In response, technicians need to either patch the damage, which provides only a limited repair and restoration of the original cross-section, or prioritize fixing the outsides of the aircraft at the expense of maintaining the engine and electronics. Furthermore, the long lifespan of the engine applies only to the newest models. The Su-34, for example, has the older version of the Saturn AL-31F engine, which has an estimated lifespan of only 1,500 hours and has been used for more than a decade. The country is also still in the process of modernizing its fleet, with half of the aircraft used in Ukraine being holdovers from the Soviet Union. These aircraft have already been in use for decades, which suggests that they're literally on their last few hundred hours of flight time remaining on the engine alone. RAND's analysis of all Russian jets suggests that its air force is flying at around 75% of its pre-war strength. RAND estimated that frequent sorties have resulted in engine degradation to the point where Russia lost another 60 aircraft. And this figure is from late 2023, only a year and a half into the war. A Polish military news website suggested in 2024 that around 45% of Russian jets are approaching the end of their lifespan and would need to be decommissioned in the coming years, with 60 jets likely needing to be decommissioned in 2024 alone. Russia could try to maintain some of them to give them a year or two, but that's not a surefire long-term solution. Even if Russia slowed down the use of aircraft by a third, which RAND posited after 2 years of flying at high tempo, it's still using aircraft at nearly double the recommended rates. 3 years into the conflict, Russia could have lost as many as 80 to 100 aircraft to imputed losses, and this figure only grows with each passing month. To make matters worse, Western sanctions have severely restricted Russia's access to specialized materials and precision manufacturing equipment needed for engine maintenance. The result is a maintenance crisis that quietly grounds more aircraft than Ukrainian missiles and anti-air defenses do. This maintenance crisis extends beyond just engines. Modern fighter aircraft depend on thousands of components with specific replacement schedules. As sanctions restrict access to these parts, Russian maintenance crews could be cannibalizing more critical aircraft to keep others flying, further compounding the loss rates of the war. These needs extend to both newer and older aircraft for slightly different purposes. For older planes, replacement parts are simply not being made at scale, with most of the planes being scheduled for part upgrades. But if the underlying system doesn't get upgraded as well, newer parts might not fit or perform as expected. Russia's air power is severely weakened by sanctions cutting off Western parts, widespread corruption, and outdated military doctrine. These issues have led to grounded aircraft, poor quality components, and insufficient pilot training. On the battlefield, Russia's defensive-focused air strategy leaves pilots ill-prepared for offensive operations, forcing reliance on older planes and imprecise glide bombs. In contrast, Ukraine has adapted better with Western support and flexible tactics. The conflict highlights that advanced air forces can be countered by strong air defenses, signaling a shift away from traditional air supremacy toward new warfare methods involving drones and standoff weapons.